Question number 10. We are told when the polynomial x to the 29 plus x to the 23 plus x to the 19, 17, 13, 11, 7, 5, and 3 is divided by x minus 1, it leaves a remainder. And you are told to find the remainder when x is equal to 2 and 3. Division of polynomials carry the same sense as just division of numbers. I will just give an example. If I take 5, I divide by 2, then we know the answer of this is 2, remainder 1. That's the idea. So 5 divided by 2 goes 2 times and 1 over. If you want to express this in such a way that this side gives you the same answer, then we will say that 5 can be written as 2 times 2 plus 1. See? 5 is equal to 2 times 2 plus 1. 2 times 2 is 4 and that. So these two and these two looks the same. I would take a different situation where that number is different so you understand better. So let's say 7 divided by 3 is going to go twice and there will be 1 as a remainder. That means 7 can be written as 2 times 3 plus 1. That's important. That's important. This 2 is there. This one is the divisor, or what we call the quotient that is going to come. In a similar fashion, we are going to look at functions when they divide themselves. So let's say this long polynomial is p of x. That means if p of x is divided by x squared minus 1, then it's going to give me a certain answer, and remember, with a remainder that's also a function. You see, now I'm using functions. Previously we had numbers, and so we had numbers here. But in the same way, like the numbers, my p of x then can be written as x squared minus 1 times k of x plus r of x. 7 divided by 3 was equal to 2 and 1 was over. We said 7 could still be written as 7 is equal to 3 times 2 plus 1. So I try to do it in the same way here. So it means my polynomial can be expressed in this form. What we have to understand is that the remainder should always be smaller than the number that's used to divide, than the divisor. So we had 7 on 3 was equal to 2, remainder 1. The remainder cannot be bigger than 3. If it's bigger than 3, then it has to go one more time. So your remainder should always be smaller. It's the same way here. We will say that our remainder here should be a polynomial of order that is smaller than this one. And the next polynomial than this is 1 to the power 1. So we will try to look at it in that sense. That means my r of x here can be expressed in the form ax plus b, where I see that the degree of this one is 1 and the degree of that is 2. It cannot be 2 because otherwise it would have divided one more time. That is the way we try to handle this here. So what is required from us then is to look for these constants a and b, given the information that we have there. I can write this in a nice form here. So it means that my p of x then will be equal to, this is a difference of 2 squares. So you can factorize that. We already saw that in this video and other videos in the Math Salon channel that you can check as well. So this is say x minus 1, x plus 1 times q of x plus, we said this can be written in that form. So this is ax plus b. Since it was divided by this, it means you can try these numbers. You can be able to put this, for example, if I put p of 1, this part will be 0 here, because this will be 1 minus 1. So all of this will go to 0, but this one, 1, a will multiply 1 plus b. So p of that will be equal to 0 here, plus a plus b. Or I will just say a times 1, so that we all see, plus b. But I can also put this into this polynomial to see what it gives. So if I put 1 into this polynomial, then that's going to be 1 to the power 29, which is 1, plus 1 to the power 23, which is 1. They will all be 1. 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. So I will get 1s 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is actually equal to 9. So I'll get my first equation that A plus B is equal to 9. If I do P of minus 1, because it's also here, you can see that I can get that form. It was divisible by that with a certain amount. So I can get that form here. So if I do that here, I would have, once again, 0 here plus, this time it's minus 1. So this will be minus A plus B. So this is minus A plus B. And if I put this also into my polynomial, then I will see that, notice, they are all odd powers. That means minus 1 to the power 2 is 1. Minus 1 to the power 3 is minus 1. Minus 1 to an odd power will always be negative. So in that case here, you are going to get minus 1, minus 1, minus 1 9 times. So we get minus 9. Therefore, I have two equations here to solve. So I have A plus B is equal to 9, and minus A plus B is equal to minus 9. If I sum these two equations, then I get 2B is equal to 0. A plus minus A goes away. B plus B is 2B. 9 plus minus 9 goes away. So B is equal to 0. If B is 0, you can just substitute in any of this. You see that then A is equal to 9. 9 there. So these are my two equations. That's good. So A is 9, B is 0. That means my remainder, which we call r of x here, is equal to 9x plus 0. But we don't write that. So it's just 9x. So if my r of x is 9x, now they're asking you what will be r when x is 2 on 3. That means my r here of 2/3 is just substituting inside. Putting there. So that's 9 times 2/3. 3 here 1, 3 here 3, and times that is 6. So the answer for that was supposed to be 6.